Subtracting polynomials. Here's an example of subtracting two polynomials. This looks kind of confusing, doesn't it? There's a lot going on here. We have each polynomial in its own set of parentheses. Then we have subtraction in between them. We also have some subtraction in each polynomial and even a negative term there. So how do we keep track of what to do with all this subtraction and negatives? Well, it would be a lot easier if this were an addition problem, wouldn't it? It certainly would. So I'm going to show you a trick on how we can change any subtraction problem into an addition problem. We'll come back to this one later. Let's take a look at a simpler problem. 28 minus 3. Pretty easy, right? Subtracting two numbers. But what if we wanted to change this to an addition problem? We can use a strategy called keep, change, change. All we do is keep the first number the same, change the subtraction sign to an addition sign, and then change the sign of the second number. So let's do that with 28 minus 3. We keep the first number the same, so 28 just stays as it is. We change the subtraction sign to an addition sign, and then we change the sign of the second number. So that positive 3 will become a negative 3. So we could have set that problem up as 28 minus 3 or 28 plus negative 3. Either way we solve this problem, we still end up with the same answer of 25. Now let's see how we can apply that to actually subtracting the polynomials. Okay, with our first example here, we see that we have a trinomial in the first set of parentheses and a binomial in the second set of parentheses, and we have a subtraction sign in between them. Let's use our trick to change this to an addition problem. So we keep the trinomial the same, change the subtraction to an addition sign, and then we're going to change the sign of each term in that binomial. So the positive 2x squared will become negative 2x squared, and that positive 4 will become a negative 4. Now we have an addition problem. So we can just combine like terms to finish this problem. We have the 7x squared from the first polynomial, combine that with the negative 2x squared in the second one. That gives us 5x squared. There's only an x term in the first polynomial, no x term to combine it with from the second one, so we bring that down. And then we can combine the constant terms. The positive 8 and the negative 4 give us positive 4. Okay, so putting it all together, our solution is 5x squared plus 3x plus 4. Now this showed this solution by using the horizontal method. We could have also used the vertical method. With the vertical method, we need to line the polynomials up so that their like terms are one on top of the other. Now we can apply keep, change, change. Keep the first polynomial the same, change subtraction to addition, and then change the sign of each term in the second polynomial. Now we can combine like terms, adding these two polynomials together. And we get the same answer as with the horizontal method, 5x squared plus 3x plus 4. Okay. Now we have a lot more going on with this problem. This is the one that we saw when we first began the video. So now let's see how we can tackle that problem using keep, change, change. Okay, we keep the first polynomial the same, change subtraction to addition, and then change the sign of each term in that second polynomial there. Negative 3x squared will become positive 3x squared. Minus 5x will become plus 5x. And the positive 6 will become negative 6. Now we can add these polynomials by combining their like terms. 4x cubed can only remain as it is. There's no other x cubed term to add to it. 3x squared will also stay as it is, no other term to combine with it. We do have an x term in each polynomial. We can now add those together. Negative x and positive 5x give us plus 4x, and negative 1 plus negative 6 gives us negative 7 or minus 7. Okay, so here's our final solution. 4x cubed plus 3x squared plus 4x minus 7. And if you prefer to use the vertical method, you can set it up the same way with one polynomial on top of the other, making sure that you line up the like terms. And then we can set up keep, change, change, changing the subtraction to addition, and then changing the sign of each term in the second polynomial. Now we can add them together. Remembering to combine like terms. Okay, and we get the same answer as the horizontal method. 4x cubed plus 3x squared plus 4x minus 7. Now it's your turn. Find the difference of these polynomials. Don't forget to use the keep, change, change method so you can change this into an addition problem, and you can pause the video if you need more time. This is what we would get after we apply keep, change, change. Okay, we kept the first polynomial the same, changed the subtraction sign to addition, and then changed the sign of each term in the second polynomial. Now we can add the polynomials together by combining their like terms. And as our final answer, we get negative 6x squared plus 7x minus 2. So you just learned how to subtract polynomials. Great job.